these two domain problems are more complicated compared to the ones you see on your textbooks. So let's take a look. We have f of x equals to x plus 7 and then times the cube root of x plus 10, the whole thing divided by 2x minus 16 times the square root of x minus 6. Before we go into the domain, let's take a look at the graph of square root of x and the cube root of x. So for square root of x, the one in yellow, we have a point starting at the origin and then the curve goes all the way to the right. So that means, look at the radicand, x must be greater than or equal to 0. So x can be equal to 0 or x has to be positive. If you take a look at the graph of the cube root of x, so we have a piece goes all the way to the right and then another piece goes all the way to the left. So in that case, other than 0 and positive, x can be negative as well, right? Because if you take a look at the cube root of negative 8, so that is equal to the cube root of negative 2 times negative 2 times negative 2, right? So that is equals to just a negative 2. But if you take a look at the square root of negative 8, that is undefined, because for cube root, I can rewrite negative 8 as a product of 3 identical factors. Okay, so let's go back to the first function. So first of all, let's take a look at the top. So the top, we have x plus 7. So if you consider x plus 7 on top, does that create any restriction? X plus 7 in the numerator. The answer is no. X plus 7, you can let x be positive, negative, or 0, no problems at all. So that means we say x plus 7 has no restrictions. How about x plus 10, the cube inside the cube root? How about x plus 10? So x plus 10 is inside a cube root, not square root. Do we need to worry about negative? The answer is no. As long as you have cube root, so I should tell you this, that works for the cube root. If you put a 3 in there, put a 5 in there, put a 7, put a 9, put a 11, they are all the same. Because as long as that number, so 3, as long as that number is odd, the radicand can be positive, negative, or 0. So if you go ahead and change the 3 to a 5, to a 7, to a 11, to a 13, to a 101, x plus 10 has no restriction as long as that number is odd. All right, so no restriction. Okay, time to work on the bottom. 2x minus 16. So 2x minus 16 is in the denominator. So therefore, 2x minus 16 cannot be equal to 0. And then you solve these equations for me. So you subtract, you add 16 on both sides, cannot be equal to 16. And then you divide both sides by 2. So x cannot be equal to negative 8. So this is your first restriction. So when you choose a number to put it into the function, do not put 8. All right. And then how about the x minus 6 inside the radical? So x minus 6, that according to the yellow graph, x has to be greater than or equal to 0, right? So this one we say that x minus 6 must be greater than or equal to 0. Take a look. Is this correct? The answer is this is partially correct. What is the problem? The problem is you let x minus 6 equals to 0. What happened when x minus 6 equals to 0? So let's say x equals to 6. When x equals to 6, we have a problem. 6 minus 6 is equals to 0. The square root of 0 is 0. I understand that, but you have this 0 in the denominator. So that creates a problem. So therefore, you have to cross this out. That is not right. You have to do x minus 6 greater than 0 only because this is in the denominator. And then solve the inequality, x has to be greater than 6. So two restrictions, x has to be not equal to 8 and greater than 6. So we put those on the same number line. So we draw a number line first. All right. And then we have a 6. We have an 8. So x cannot be equal to 8. So we punch a hole right there. Do not let x equals to 8 and greater than 6. So we have a 6, but we have to skip 8. And then we go all the way to the right. All right. How come you don't use an solid circle on A because x cannot be equal to A. How about 6? X cannot be equal to 6 either, so that's why there is no square bracket and no solid circle. So for the square bracket, this is the first interval from 6 to 8, all parentheses, because 6 and 8, they are both open circle. And then from 8 all the way to infinity, so we write 8, comma, past infinity. When you write interval, you always put small number on the left, followed by a comma, and then a big number on the right. So this is the domain of the first problem. What about the second one, the g of x? So for the g of x, on top we have x plus 7. I mean x raised to the 7th power. Does that have a restriction? The answer is no, right? So x to the 7 is on top, so you can let x be any value you want, so that one has no restriction. How about the square root x plus 20? So the x plus 20, so in the previous problem we have a cube root, but this time we have a square root. Do you see that? Do you see the 3? Look all the way up. Do you see that I put a circle on 3? Right there, the first one, the f of x. I use a cube root, but the pink one, that is a square root. Square root means there is a 2 in there. So that means x plus 20 must be what? Must be greater than or equal to 0. Think, can this be equal to 0? The answer is yes, because x plus 20 is in the numerator. It is okay to have 0 in the numerator, so that's why we use as equal. And then x must be greater than or equal to negative 20. So this is my first restriction. And then let's look at, before we go to the bottom, so for go take a look at the function. We have a square root, right? So this works for the square root, the 4th root, the 6, the 8, the 10, the 12, 14, 16, 18, 20. As long as that number, so this one I can put a 100th root right there. So look all the way up. I can just put a 100 right there. As long as that number is even, then you can put greater than or equal to 0. All right. And then let's look at the denominator. So the denominator, we have x plus 10, right? So what's the restriction? X plus 10, what's the restriction? For cube root, x plus 10 can be positive, negative, or 0. But can you use 0? The answer is no. You have that in the denominator, so no 0. So cannot be equal to 0. Positive is fine, negative is fine. You can have positive or negative in the denominator except 0. So that's why we write x plus 10 not equal to 0. So x is not equals to negative 10. So that is the next restriction. And then how about the last one? Negative x minus 6. Can that be greater than or equal to 0? No, right? So that is not right because you cannot use equal. Once you put an equal, that means you have 0 in the denominator, so which screw up everything. Then the correct answer is negative x minus 6 greater than 0, and then you just solve this. So negative x is greater than, add 6 on both sides, and then you multiply or divide both sides by negative 1. Remember this rule for inequality. Once you multiply or divide both sides by a negative quantity, I don't care negative what, once you multiply or divide both sides by negative, you have to reverse the inequality symbol. So x is less than negative 6. So this is the next restriction. And then I am going to draw a line to summarize these 3 restrictions. So I have a negative 20, I have a negative 10, I have a negative 6. So no negative 10. All right, so we put an open circle greater than or equal to negative 20. So we use a solid circle, and then we go all the way to the right because that is a greater than, but we have to take a stop at negative 6, and negative 6, that is a less than, so we have to draw a line to the left. So now they are connected. So this is the domain, and then you use interval. So that is square bracket because x can be equal to negative 20. So negative 20 is okay. So that's why we use a solid circle. Solid circle corresponds to square bracket. So negative 20 to negative 10, comma, from negative 10 to negative 6. And then for inequality, you can write x between negative 20 and then less than negative 10, or x negative 10 less than negative 6. So that is how you store the domain of the function g of x. Alright, so that is the end of this video. If you think my instruction is helpful, give me a like, share the video for me, subscribe to my channel if you're on your way out. I will catch you all in the next video.